Here we have the next topic, principle of moment. And once again, this is a topic that you have already studied in your IGCSE or O-level physics. And once again, the new variation in this one would be the forces which are not perpendicular to the distance, or when the force and distance are not perpendicular to each other. So what you'll need to do is you'll be required resolve the force or resolve the distance into components. Okay, that would be the only tricky part here. Anyway, let's start it off. First of all, we need to write or state the principle of moment. They ask you this question for 2 marks, and what you need to write is note it down. So this is how we define the principle of moment. If you write only the red part, you get 1 mark only. So you gotta add this thing as well for an object in equilibrium. So if an object is in equilibrium, it means the sum of clockwise moments equals the sum of anti-clockwise moment about any point. Alright, so you can write this as well, about any point or about a point, because we always take a pivot before we find or before we start calculating the moment of a force. So let us take a look at the example. Here I have a sample question. इसको देखते हैं कि how do we solve this one. अच्छा, so the diagram is given और इसका question ये है आपका. Alright, and we assume that the forces would be balanced. The forces upward and the forces downwards are equal. So the first condition of equilibrium is being satisfied. Now the second condition of equilibrium is that the sum of clockwise moments should be equal to the sum of anti-clockwise moments about any point. This is what the principle of moment reads. Then the object would be in equilibrium. Achha, in order to solve this kind of question, you see we have plenty of forces. You have first force over here, then there's another force, then there's a third force, and then there's the fourth force. The very first thing is that you need to select a pivot. You need to choose a point that you'll be calling the pivot. So you can call this point the pivot. You can call this point the pivot. We can call, let's say, X the pivot. We can call the point Y the pivot. We can call the point Z the pivot. And the last one, let's call it W. We can call the point W the pivot. Now the thing is, out of these possible options, what point should we consider as a pivot? And the answer is, in this special case, in this situation, if we consider the point Y, this point the pivot, what's going to happen is the force that is passing through the pivot, in this situation it is a force R, which is unknown. So if you consider the very same point as the pivot, there would be no turning effect of force because of this force, because the line of the force is passing through the pivot. ठीक है, ये इसी तरह the common example would be कि you need to open the door or close the door, लेकिन जो force है वो आप hinge के ऊपर, वो जो pivot होता है door की opposite to the handle side, जो hinges हैं, hinges के ऊपर ही आप force लगाते रहो. There would be no moment of force where the force is passing through the line of the pivot. This is precisely why we use this point as a pivot, ताकि ये force आपकी कोई moment of force produce ना कर सके. Because अगर ये force moment of force produce करेगी, then we need to find the moment of force produced by this force, and then the problem would be, in order to find the moment of force, you need to apply the formula force times perpendicular distance, but the value of this force is not given. कितने न्यूटन है we don't know. So that's why हम इसी पॉइंट को पिवट ले लेंगे ताकि ये फोर्स मोमेंट ऑफ फोर्स प्रोड्यूस ना कर सके. The remaining three forces would be producing the moment of force. उसको हम कैलकुलेट कर लेंगे. This O is your pivot. So we are left with three forces. Let's check out the forces which will rotate this bar around the point O clockwise and which forces will rotate it anti-clockwise. So देखो यहाँ से आपका होल्ड हुआ है pivot at the point O. So the force of 10 Newton, it would bend the rod in this direction, something like this, which is anti-clockwise. So इसके साथ मैं A लिख देता हूँ because this force would produce anti-clockwise moment. Likewise, the force of 5 Newton, ठीक है, ये भी रॉड को इस तरह से बेंड करेगी, टर्न करेगी. So this would also produce anti-clockwise. We can write A with it. And the last force, 4 Newton, it would bend the rod in this direction, which is clockwise. So इसके साथ C लिख देते हैं. Now we apply the principle of moment, which says the moment of force, clockwise moment of force, should equal the anti-clockwise moment of force. अगर वो equal आ गए, the object would be in equilibrium. अगर किसी एक side पे the sum of moment of force ज़्यादा आ गया, then the object cannot be in equilibrium. So let's find the sum of moment of force anti-clockwise first. So anti-clockwise के लिए दो forces हैं, first this one and then this one. So what is the first force? 10 Newton. अब इसका moment find करने के लिए we need to multiply this force with the perpendicular distance of this force with the pivot. तो ये force जो 10 Newton है, इसका perpendicular distance है आपके पास 1.5 meter. तो moment कितना हो गया? 10 times 1.5 plus, because there's another force that is producing anti-clockwise moment. कौन सी force? 5 Newton वाली. So that was the other force. And what is the perpendicular distance of this force from the pivot? 2 meters. देखो यहाँ से axis of rotation तक जो perpendicular distance बन रहा है 2 meters है. So that equals to 5 times 2. And that equals now let us find the sum of moments of force clockwise. So clockwise आपका एक ही force है जो इसको clockwise rotate करेगी. So you don't need to add any other moment of force which is there clockwise. सिर्फ एक ही आपके पास, which is the force of 4 Newton. Now how much moment of force would this force produce? That equals to F into perpendicular distance of this force. तो इस force का perpendicular distance कितना pivot से? 5 meters. ठीक है, is given over here 5 meters. So this is the overall the sum of moments of force anti-clockwise, and this is the overall moment of force clockwise. तो अगर तो ये दोनों equal हो गए, the object would be in equilibrium, और अगर equal ना हुए, then the object would be rotating. So let's solve the left side. So what do we get is 10 times 1.5 would be 15 plus 10 equals 5 4s are 20. So आपके पास आ गया 25 और यहाँ पे कितना आ रहा है आपके पास 20. So that means the moment of force, overall moment of force anti-clockwise is not equal to the overall moment of force clockwise. तो आपका ऑब्जेक्ट इक्विलिब्रियम में नहीं होगा. Okay, so we can write the final verdict here. Object is not in equilibrium. All right, object is not in equilibrium. There is a resultant moment of force. और कितना resultant moment of force है? You can subtract these two. 25 minus 20 and you get 5 Newton meter. So there's an additional 5 Newton meter moment of force. किस साइड पे ज़्यादा है? एंटी क्लॉकवाइज. ठीक है, ये हमारी साइड थी एंटी क्लॉकवाइज और द राइट साइड वाज क्लॉकवाइज. सो एंटी क्लॉकवाइज पे जो मोमेंट था, ओवरऑल मोमेंट, उसका आंसर आपका ज़्यादा आया. दैट वाज 25. सो इन ऑर्डर टू बैलेंस इट or in order to make it in equilibrium, you'll need to produce an additional moment of 5 Newton meter clockwise. So moving on to the next page, you can scroll to the next page. So we have the single pivot problems, and you'll see in the next few pages we'll be dealing with double pivot problems as well. और वहाँ पे मैं explain करूँगा what do we do if we have two pivots or we have to consider two pivots at the same time. Then we can make use of the simultaneous equations, and there are different ways you can solve it. But right now we have the single pivot problems. So this is your pivot labeled with the letter P. There's a first force, you can call it F1 or whatever. This is of 350 newtons, and the perpendicular distance between this force and the pivot is 2 meters. Then you have the second force, which is at a distance of 5 meters. ठीक है, directly नहीं given 5, but we can know indirectly that the distance of the second force from the pivot is 5 meters. But that force is not perpendicular with the distance. ठीक है, वो जिस point पे लग रही है वो तो आपका 5 meters away है, लेकिन the force is not perpendicular to the distance. Rather, the force is making an angle of 40 degrees with the vertical line. So whenever you have a situation like this, you can resolve either the distance or the force. And in this situation, it would be better that if you resolve this force, because you don't want to resolve the distance because there's another force that is already perpendicular to the distance. So the problem is, you can say the problem is with this force only. तो इसको हम components में resolve कर लेते हैं. So one of the component can be in this direction. Let me draw over here. So this can be one of the component of force upward, and the other component of force we can show over here. Okay, so we draw the components in a smart way. We ensure that one of the component of the force should be perpendicular to distance and the other component would be aligned with the distance. So you see, once you have drawn the components, then you need to label these components. So this is the force F. This component would be F cos theta or F sin theta. What do you say? जो आपका component है upward, would it be F cos theta or F sin theta? Since this component is directly with the angle, so that is the indication. The component that is directly with the angle, जो आपको angle के साथ वाला component given है, that is a cos theta. and the other component would eventually be sine theta. So नीचे वाला आपका हो गया f sine theta, and the angle is 40. So instead of theta, we can write 40 here. Now in the calculation, because you need to find the value of f, and the thing is the system is in equilibrium, means you can apply the principle of moment. The clockwise and the counterclockwise, those moments would be equal. So we can safely apply the principle of moment. So we have one of the force here. This force would produce the moment, and the second force that would produce the moment is not F, rather it would be a component of F, which is F cos theta, because F cos theta is the component which is perpendicular with the distance. You see, only F cos theta is perpendicular with the distance. F sin theta is parallel to the distance. So वो वाला component would not be responsible for moment of force. So आपके पास दो forces आ गई, the ones that I have highlighted. According to the principle of moment, the clockwise moment should be equal to the counterclockwise moment. So this force would produce clockwise moment. If this is your pivot over here, then this force, if you push it downward from here, then your bar would move clockwise. So what is the clockwise moment? That equals to 350, the force, times the perpendicular distance, which is 2 meters. And that equals to the anti-clockwise moment. And the anti-clockwise moment is the force times the perpendicular distance of that force from the pivot, which in this case is 5 meters. We can add 2 meters and 3 meters. So that equals to F cos theta, F cos 40 times 5 meters. So from here, you can simplify it to find the value of F. You can rearrange it or multiply 350 by 2. You get 700. And make sure when you're using it on the calculator, आप ये ना कर देना कि cos 40 multiply by 5. So what the calculator would do is, calculator पहले इन दोनों को multiply कर देगा, cos 200 आ गया, and then calculator would find cosine of 200. But we don't want it. We want to find the cos 40 first, and then we want to multiply the answer with 5. So it's better you enclose cos 40 in brackets और फिर उसको 5 से multiply करो. Alright, let's move on to another question. It is from the paper of 2022. I don't know which variant exactly, but from 2022. 4 beams of same length each have 3 forces acting on them. Which beam has both 0 resultant force and 0 resultant torque acting? So first of all, we can find out which one of these options have 0 resultant force. So let us start off with the first one. The total force upward is 10 plus 27, which is 37. But the force downward is not 37. So upward force is 37, downward force is 90. They are not equal, so the resultant force is not 0. So it can't be A. We can throw it out the window. Let's check out the option B. The total upward force is 50 plus 71, which is 121, but the downward force is not 121. So ये cancel तो हो नहीं सकती. So resultant force cannot be 0. We can cross out the option B. Let us take a look at the option C. Or let's take a look at the option D first. The total upward force is 43 plus 12. What do we get? 55. But the total force downward is not 55. It's 60. So the resultant force cannot be 0. So the only option we are left with is C. And that makes sense also, because the total upward force is 15 plus 25. The total upward force would be 40 Newton, and the total force downward is also 40 newtons. So they'll cancel out each other. Resultant force would be 0. And if you choose this point as a pivot, you find out the moment produced by that force, which would be 15 times 550. That would be equal to the moment produced by the other force, 25 times 300. So you can hit it on the calculator. There would be no resultant moment and there would be no resultant force. So let's move on to the next question. Here we have the next one. And the question is, a uniform meter rule is hung from the ceiling as shown. Okay, then we are given with the diagram. The rule balances when a 75 grams mass is hung from the other end of the ruler. What is the mass of the meter rule? And the most important thing here is you need to check out the data. They have said that the uniform meter rule. So uniform meter rule means the center of mass of the meter rule would be exactly in the middle. So it is a meter rule. It has total of 100 centimeter. So the center of mass would be at 50 centimeter mark. So this is a point through which the entire weight of the object seems to act. So this is your center of mass, and this is a point through which the weight of the meter rule would be acting. And then there's another force which would be through this thread, that is the tension in the string. So we have a total of 3 forces. One force would be here. Because of this mass of 75 grams, there would be a weight, and that weight would be a force. The other force is the tension upward. The third force is the weight of the meter rule itself. So in order to apply the principle of moment, what we have to do is, and how do we know we can apply the principle of moment? Because it reads the rule balances. Means in this situation, when you have hung the mass of 75 grams, then you can apply the principle of moment because the rule balances then. So we can apply the principle of moment in this situation. In order to apply the principle of moment, we need to select a pivot. Other thing is, यहाँ से किस चीज को हमें pivot select करना चाहिए. So let's say the answer is pretty clear, but I want to explain it. There are 3 possible options. The first one, point X. The second one, point Y. The third one, point Z. So we can choose any 3 of these points as the pivot. इसके अलावा भी कर सकते हैं, but these 3 would be the most suitable options. और हमने देखो, at the same time you need to keep in your mind कि आपने find क्या करना है, mass of the meter rule. Okay, so be it mass or be it weight, it would be the same thing. We can do the conversion, or conversion ना भी करें, I mean we can use the principle of moment, but we can use it in terms of mass. Mass की terms में भी use कर सकते हैं, because force in this case equals to weight, and weight equals to mg. The value of g would be same for all the masses, so the value of g would be cancelled out. So we can use the principle of moment in terms of mass as well. So m1 d1 equals to m2 d2. This equation can also be used. अगर आपके पास mass given है, use the same one for the masses. अच्छा, the point x, if I consider the point x as a pivot, what's going to happen is कि this force जो 75 grams इसको weight में convert कर लो, या this mass would not be responsible for producing the moment because this would be passing through the pivot. So you will be having only two forces producing the moment. One of them would be T, one of them would be W. So W तो आपने find करना है, but the problem is you don't know the value of T. So you can't be finding two things from the equation, and both the things are unknown. I mean, it would be impossible for you to find the value of W. You can find the value of W only if you know the value of T. So considering the first point as the pivot is not a good option. So what if we consider the point Z as the pivot? अगर point Z को pivot consider करें, इस point को. Well, if I consider this point the pivot, तो इस point से जो आपकी force गुजर रही है, that is W, that force would not be responsible for the moment of force. So that force would be wiped out from the equation. ये तो moment of force वाली equation में आएगी नहीं. So how do we find the value of W? अब एक चीज़ जो आपकी equation में ही नहीं आएगी, उसकी हम value फिर कैसे find करेंगे? So that's the reason कि considering Z as the pivot is not a good option. The only sensible option would be considering the point Z as the pivot. इससे क्या होगा? The force that is passing through this point, which is T, would be out of the equation and it would be good for us क्योंकि हमें T की value वैसे भी नहीं पता. And if we don't use it in the equation, it would be okay for us. They didn't ask us to find the value of T, तो हम इसे ignore भी कर सकते हैं. So we consider the point Y as a pivot. This one would rotate it clockwise, sorry, anti-clockwise. This one would rotate it clockwise. So what we can do is M1 D1. What is M1? 75. What is D1? The distance of this force from the pivot. It's ending at 34 and starting from 4. So it would be 30 equals M2 would be written as it is. ठीक है, mass की terms में ही consider करते हैं, forget about the weight. So M2 we need to find out. So we write it down as it is. But what is the value of D2? D2 is the distance between the second mass and the axis of rotation. So it is from 34 to 50. So 34 से 50 तक, 34 से start हो रहा है, 50 पे end हो रहा है, so it would be, alright, and no need to convert the units. You don't need to convert centimeters into meters because you're not getting the answer in centimeters or meters. वो eventually cancel out हो जाएंगे. Your answer would be in the units of mass, which means the centimeter or the meters or the units of length, they are all cancelled out. So if you find out the value of M2 from here, just use a calculator. You can write it as 141. So we need to find the vertical force F. This force needs to be found out. This force needs to be found out. The distance of this force from the pivot is given. Then there's a second force. The distance of that force from the pivot is also given, which is 12. Then there's third force. The distance of that force from the pivot is also given, 35. And all the distances are perpendicular distance from the pivot. So all you gotta do is add clockwise moments on one side and anti-clockwise moments on the other side and write them equal to each other. And from the equation, from there, you can find the value of F.